Hello, and welcome to the Data Engineering Podcast, the show about modern data management. Data teams everywhere face the same problem. They're forcing ML models, streaming data, and real time processing through orchestration tools built for simple ETL. The result? Inflexible infrastructure that can't adapt to different workloads. That's why Cash App and Cisco rely on Prefect. Cash App's fraud detection team got what they needed: flexible compute options, isolated environments for custom packages, and seamless data exchange between workflows. Each model runs on the right infrastructure, whether that's high memory machines or distributed compute. Orchestration is the foundation that determines whether your data team ships or struggles. ETL, ML model training, AI engineering, streaming, Prefect runs it all from ingestion to activation in one platform. Whoop and 1Password also trust Prefect for their data operations. If these industry leaders use Prefect for critical workloads, see what it can do for you at dataengineeringpodcast.com/prefect. Composable data infrastructure is great until you spend all of your time gluing it back together. Bruin is an open source framework driven from the command line that makes integration a breeze. Write Python and SQL to handle the business logic, and let Bruin handle the heavy lifting of data movement, lineage tracking, data quality monitoring, and governance enforcement. Bruin allows you to build end-to-end data workflows using AI, has connectors for hundreds of platforms, and helps data teams deliver faster. Teams that use Bruin need less engineering effort to process data and benefit from a fully integrated data platform. Go to dataengineeringpodcast.com/Bruin today to get started. And for dbt Cloud customers, they'll give you a $1,000 credit to migrate to Bruin Cloud. Your host is Tobias Macy, and today I'm interviewing Michael Toy about Malloy, a modern language for building composable and maintainable analytics and data models on relational engines. So, Michael, can you start by introducing yourself?
Hi, I'm Michael Toy. I'm one of the creators of Malloy.
And do you remember how you first got started working in data?
Yes, the way I got started working in data is that a friend dragged me into his company, and the friend is Lloyd Tabb, who's the other co-creator, co-discoverer of Malloy. And he's someone who's been passionate about data his whole life. I'll probably be talking about Lloyd a lot because his vision of what the data experience should be is a huge influence in what Malloy is. He started a company to build a data tool, and he said, "Hey, you want to come start with this company with me?" I said, "Oh, that's stupid. Nobody pays money for tools." And then a year later, I didn't start the company with him, but I joined him, and then that company became Looker, which was a big deal. I don't know. Well, we did pretty good. And so I worked a lot on making Looker, and that was my first experience in being seriously involved in data as opposed to using data.
And so, digging now into Malloy, can you give a bit of an overview about what it is and some of the story behind how it got started?
Well, sure, and it's kind of bound up in the history of Looker and of what problems exist in the world. So there's a set of problems in trying to understand what the right user experience is to create for people who are trying to do work based on data. And Looker was an attempt to address some of those things. And at the core of Looker, there's a thing which we now call semantic modeling. I don't know what we called it before Looker, but now that Looker exists, everyone calls it semantic modeling. I don't want to claim that we invented it, but we did it really well, where you could write the SQL for your model like you always did, but you had to write it in kind of a structured way so that there was enough metadata about your computation so that you could mix and match and sort of compose queries based on what the user wanted to see, and then you could compose the SQL from there. And Looker was main selling point for Looker when we walked into people who'd never seen Looker before was, look, it's just SQL, right? Everything that's getting written here is either SQL that we're generating or that you wrote yourself, and look at the queries we're writing and they're just SQL. And Looker was tremendously successful, but there were some places where SQL itself was kind of in the way, and it needed to not just be SQL because the data surface of SQL doesn't really match great to the way that people like to think about data. But we made a multi-billion-dollar company on a pretty good idea, and that was great. But as Lloyd and I stopped being so involved in the day-to-day operation of Looker, and then Google bought Looker, we had some time to say, well, what should data look like? And so Malloy was just, we had some time to sort of take a fresh cut at thinking about how to interact with data, and our frustrations with Looker resulted in Malloy. It's a
And so, in terms of the Malloy language and project, as you mentioned, SQL can be very verbose. It can be very obtuse to try and get to the thing that you're really trying to do. And it is also verging on the area of Perl of being a write once, read never language if you're not careful. And so, in terms of Malloy in particular, I'm curious what the core problem is that you're trying to solve and who you're trying to solve it for.
Yeah, well, this is where so I'm going to claim to be some things that I am not, but let's pretend that I'm standing in for all the people who did a thing. And when I say I really mean we, because I don't want to be weird about it. And a lot of the stuff that I say I is me, and a lot of it is me and the people I worked with. So I am the person who's responsible for the language, designing the language, implementing the language. That's not true. There's a bunch of other people who did a ton of this work, but let's pretend it's just me, just for the purposes of this conversation. And then Lloyd is the person who is responsible for, I have spent my entire life figuring out how to make great user experiences with data forever. And every place I go, this is the job that I'm solving, and I know more about this than anyone in the world. He wouldn't say that, but I would say that because I've watched him work, and I wish Lloyd were here to say great things about me, because I'm sure that would happen too, because he also thinks highly of me. So when we come to this problem of what's the best way to think about data and can it be expressed as a language, I'm super passionate about all the ways that computer languages work, and so a lot of things you mentioned about SQL are true and shouldn't be held against SQL, because SQL is, I don't know, 45 years old. It's a quite old computer language, and we've learned a lot about computer languages since then. And if someone were designing SQL today, they would write a different language that didn't have all those problems, because we've learned a lot about software engineering. And so I am passionate about all those things, and I've tried to fix absolutely all those problems in the design of Malloy. That it's a computer language which is, composable, so that you can build things out of smaller things and glue them together, and predictable and readable by humans, and a bunch of things that modern language are that SQL isn't. But then the other impetus for Malloy is not even really as a language. So there's I'm going to try and channel Lloyd here. So all interactions with data should be interactive and open-ended, so that at one point the traditional way that data worked is there's a big room with spinning disks in them, and then there's some people who write SQL to reduce that down to a smaller subset of data, and then there's some people who worked on that smaller subset of data who then hand that to a curated version of that to decision makers, and then all decisions are being made on 3 generations away from the original data. So I've got a spreadsheet that only the CFO sees, and that's the ground truth for the company, but only one person can have that because it's so highly curated by the time it gets to that person. But all data interaction should be iterative and open-ended, means that at any point, if I'm holding a piece of data, I need both the insight of this piece of data reveals and all of the context that went into its generation, so that I can ask the next question, right? And that any time that I produce a thing that's a dead end, I've limited your ability to do the right thing with data. And so we didn't start to design a language. We started by saying, in a world where there's no SQL, but there is SQL, because SQL tells us a lot about data that we shouldn't ignore. What are these sort of objects and actions of humans who are on a sort of iterative data journey? And then once we sort of know what that is, then what's the natural language of someone on that journey? And if we describe the problem of SQL, first of all, I'm going to say a lot of bad things about SQL, but SQL is great. There's so much software engineering into making these SQL engines be able to do the things that they do. And Malloy generates SQL, and we think of SQL as the assembly language of data. Like, if you want to do things with data, the machine that should be doing your data thing is SQL. We just shouldn't ever ask humans to write SQL. That's just an unfair thing, in the same way that we don't ask humans to write assembly language. Well, there are, if there are 1 million programmers in the world, there are 10 who write assembly language. We would love to live in a world where if there are 1 million people in the world doing data work, 10 of them have to write an SQL, and everyone else says, I have no time for that, and I really don't need to, because I get my work done faster another way. So anyway, what are the objects and what's the natural language of someone on that journey? And I lost my thread. I was busy praising SQL.
And I think that's a good transition to the topic of the numerous projects that have tried, and some of them have partially succeeded. Many of them have faded into the mists of time as far as trying to be a layer above SQL and compile down to SQL, or completely obviate SQL. And some of them are trying to be more pure to the original concepts of relational algebra. Some of them are just trying to be a way of being able to do some string smashing to generate some SQL. I'm going to call out DBT in that regard. And then there are numerous various ones that are various points along that continuum. And I'm wondering if you can give your stance on how you think about Malloy in that overall ecosystem and some of the things that you've learned from your predecessors.
Sure. So I would put Looker in the string smashing to generate SQL universe. So we've certainly been in that world for a while. And again, the reason that the history of Malloy is we want to have a user-centric view of data interactions, and then we want to build an ecosystem to support that. And it turns out that the language that you use to describe what's going on with data strongly influences how you think about the journey. And one of the reasons that SQL is a problem is it forces everybody to think about data like SQL does. And SQL thinks about data in a way which is super useful, like to generate efficient queries, but it doesn't necessarily think about data the way that people do. And if you ever sit down to write, I'm talking to the wrong people. Anyone who's done any querying in SQL just knows that, like, I have a simple question and now I have to figure out how to write join statement, right, that doesn't blow up the database, that answers my question, and everything is inverted from the way that I like it to think about it. And so SQL is a problem there. And then SQL is also a problem because it's an ancient language. And so there's an opportunity to replace SQL, which we took, but replacing SQL isn't a goal, right? Our goal is all data interactions for all time should be done through the Malloy view of what data is, and then executed by SQL engines. Did that answer the question? Oh, and what makes Malloy stand out? It's based on what questions do we need to ask, what operations do we need to do in order to answer questions, not what is what's relational algebra and how does data sit on disks, and those aren't part of Malloy. You can things that you do in Malloy result in those kinds of operations, but those aren't your nouns and verbs. Your nouns and verbs are what's the information I have and what's the relationships between these different pieces of information and what do I wish I knew, and keeps you focused sort of on the tasks that you want to, like any good high level language, right?
I think it's also interesting as far as the overall history of SQL and the patterns around it that it's only in, I'll say, the past decade, maybe even more recent than that we've really started to invest in SQL as a version controlled language rather than it being just a pile of SQL scripts that somebody has in a drive somewhere or stored in their DBMS or stored procedures. And I'm wondering how that change in the approach to SQL, particularly in the analytics space, has changed some of the ways that people think about what SQL, or I guess the job of SQL and the ways that they're using it, and in particular the complexity of the operations that they're trying to do versus just relying on maybe ETL scripts where most of that logic is in a programming language that happens before the data even lands in the database.
Yeah, no, I think, again, this is a place where Looker was kind of forward looking. So you're crafting some sort of data experience. You have, your users and your transactions, and then your business things that are happening. You're trying to build dashboards and insights based on that. And there's what that looked like yesterday, and then there's the better thing I'm trying to do today. That's going to be a new version of that. And so Looker had a full IDE and with branches and commits and all those things, and some way for you to roll stuff out like real software engineering, not because we're brilliant. We're like, we know how this works in software, and this data interface that we're creating is just software, and we just want the things that we know to be good in software to also be good in data engineering. And so this isn't to us. It's like we already decided that these curated data experiences are things which change over time and are software and should be treated like software. And so it was like that was a no-brainer. I mean, the more interesting question to me is there's still sort of two data universes that are not well integrated, and I sometimes wonder why that is. One is all of the things that we would call data, like columns of numbers and names and timestamps and stuff. And then there's the other data, which is this curated set of data transformations, and they just sit in completely different places and have completely different rules for like how you access them and how you change them. And if you say, well, we should put all of Malloy code in the database, like, well, that really breaks because databases are designed to have certain kinds of controls over like who can do stuff and who can not do stuff, and it gets really clumsy to try and like, oh, I want to add a new table. Oh gosh, you need to file a form with somebody to add a new table because I mean, not because there's bureaucracy. There are reasons that there are controls like that on the data, and we think of data as a thing which has a certain kind of controls. I think of source code as things have a different kind of controls. It continues to feel to me like if we just thought about this better, that all data could sort of live in a beautiful world where you could get version control on and branches on data like you do with source code, right? And you could get sort of infinite shareability because everybody's looking at the same data. That they could live together, but I don't know how that works.
Yeah, it's definitely another whole problem that people are working on solving, just the idea of versioning data and the challenges of data
Yeah.
gravity. And
Well, and we know that it's a great thing because we in this other world of data, we do that all the time and it's super useful. And if you think about it well, it's not that expensive, right? But you just need to have a high enough level of view of what it is to actually implement it.
I think another interesting element of what you're doing with Malloy is the audience, where SQL as a language was originally conceived of as something that was close enough to English that business users would be able to write it and execute it, which never truly came to fruition. There are pockets where there are people who are somewhat removed from the engineering department who do write SQL and are able to explore things and fulfill their needs, whereas Malloy is much more targeted at a software engineering audience. It's treated as a programming language. It has elements of composability and reuse, which SQL never really incorporated. And I'm wondering how you think about the design of the language given the original formulation of what SQL was supposed to be versus where we are today.
Of all the people in the Malloy project, I'm the perfect person to ask about this because I've thought about this more than anybody. So there's been a long-standing experiment in programming languages to make them like human speech, and none of those have been long-term successful. They all sort of like bubble up and then go away. And I have my theory about that, which I will now stand on my soapbox and speak of, because a lot of this goes into why Malloy is designed like it is. One of the most important activities in some sort of long-lived maintainable piece of software is I open it up and throw it on a page, and then with my eyeballs, I understand something about its structure. And so it's like I'm flying over a city, and I can see that there's the football stadium, and there's the high school, right, and there's the place where people live, and there's the thing that's obviously the industrial district, and I can kind of see at 10,000 feet where those pieces are. And then, if I had an airplane that I could steer, I would then go land in the place where I needed to land and then walk around and do the things that I needed to do. And so when you're scanning a piece of code and it's a conversation, right, you have to read the whole conversation to know what the pieces are that you need to change. And so having some textual markers so that as your eyes scan across it, you know what parts you don't have to read is super important. And a lot of that has gone into the design of why Malloy is designed both top to bottom and left to right where it is, so that you can get to the part that you need to care about and not the parts that you don't care about. And so I have tremendous respect for I often use the word poetry, for the poetry of a programming language, that when you read a sentence, you know in your gut what it means, right? That the words make sense to you. And so like that Perl would be the worst language in the universe for this. There's no poetry in Perl. I've written significant applications in Perl. I don't want to say bad things about Perl, but there's, I've been around a long time and did a lot of things. But it being poetic is not one of the things that's great about Perl. Perl is only poetic after you're a Perl expert. And so there's a human dimension that individual sentences need to read and scan, like, oh, I don't even know the language, but I kind of know what you're doing there. That matches well to SQL, where you're saying, sum of cost, right, from table, right? You go, oh, I know what's happening. And that whole thing is a sentence which scans to human beings. So in the design of Malloy, we started with, we're just going to sit inside of SQL. Like you could write a select statement and whatever the Malloy version of a select statement is, which we originally called an explorer. And you could, there's a tool which turns the Malloy into SQL, and it's just sort of like a macro. And sometimes I regret walking away from there, and that the reasons that we did that are interesting. But we eventually walked away from there, and our new position was most of our users are experts in SQL, and so we don't want to be surprising to them in places where we don't have to be. But we do want to be surprising to them in places where they actually need to think about data differently to get stuff done in Malloy. And so we have a where statement and a having statement, and we use those words because that's what SQL users expect, right? and select and select. So we try to use SQL words and SQL gestures wherever we can, because not because we think that's the best way to talk about data, but because all the people who are really experts in data already know those things, and we want to be useful to them.
I think that the elements of the language are very important, and I think it's also interesting the ways that you are constrained in terms of the keywords and semantics of the language when you do have another target language that people are actively developing in. So I think the closest parallel that we have is probably things like TypeScript to JavaScript, or the various JavaScript transpiled languages that we've had over the past few years. And I'm wondering just how having that target representation as the intermediate state and the existing corpus of experience and reference material changes the ways that you think about what the language can and should do and how it can and should be structured.
Okay, well, there's a bunch of different questions. First of all, I want to say this about JavaScript. I wish I could remember the name of this guy. So this is, I think it's a gentleman at Microsoft who did a really interesting video, and his video was, let's look at the transition from C to C++ and the transition from JavaScript to TypeScript, because one of those is, I mean, at this point, people who are switching from C are switching to Rust instead of C++. Like C++ never really replaced C, and TypeScript replaced JavaScript. Like you turned around and suddenly everybody was programming in TypeScript. And he was theorizing about why, well, what's the difference between those two things? Because maybe as language designers, we could learn from that. And he was trying to kill C++. And so he wanted to learn that lesson so that he could, kill it better. And one of his theories was that the thing that TypeScript did really well is it sat in the tool chain, right? Like any place where you needed JavaScript, TypeScript sat perfectly, so it was not hard to decide to use TypeScript at any one time. And in fact, you could write a line of TypeScript and then a line of JavaScript and then a line of TypeScript if you wanted to in one file, and it would work okay. So in Malloy, the relationship with Malloy and SQL, because we just are generating SQL, you can, with some limitations, write some Malloy and some SQL and some Malloy and some SQL and sort of build a computation or a set of computations that use mixed expressions, and you can choose the expression that works best for you. But the initial reason that we did that is that initially Malloy didn't do very much, right? And so yes, if you wanted to group by some things and add up some numbers, Malloy would be great. But as soon as you want to do something complicated like a window function, or then you'd have to go to SQL, and we wanted to be able to show Malloy doing interesting things. And so we had a way to say, oh, there's this little piece of SQL here in this corner. We don't yet implement that, but here's this computation which is all in Malloy for this little piece of SQL, and the reasons that you would escape to SQL continue to exist, and we would like to make them all go away, but they still continue to exist. Okay, so that was on the relationship between one language and another. So we would love to be as easy a decision as like Java and JavaScript. Those are really two different languages. They have the same name for reasons, and actually I was at Netscape when JavaScript was invented, and so was Lloyd, and we were both involved in that, and so I know a lot why JavaScript is called JavaScript. It was called LiveScript at one point. We thought that Java was going to take over the universe, and we thought that calling it JavaScript was going to be the thing which made people take it seriously, because it was just as powerful as Java. But TypeScript and JavaScript is a great example. We would love to be as sort of fluid and fluent between those two as possible, which is again another reason why we would like them to, as much as possible, not have cognitive dissonance between them, except where it's necessary. And I felt like there was a third point. And so that was the other thing that I wanted to say, is that in SQL, the most important verb in SQL is the join, right? That all the magic of computations come from being able to write creative joins, right? And that the people who are really good at writing SQL can do things with joins that blow your mind. But so I've been working in data for over a decade now, so I'm not a complete newbie, but I cannot tell you the number of times in the last year that I've had to sit down with an LLM and say, hey, let's talk about join types again. Explain them to me again so that I can make sure that I'm thinking about this right as I do this thing. Because really, I want to do this kind of operation, but what do joins do? And how is that useful to do the thing that I want to do with data? It's just not the way that humans think about data. It's the way that a mathematician thinks about data, which is an important thing, because the fact that they are mathematical is super useful, right? But the the pieces of joins that you need to use, you'd like to be able to express those in a way which is human understandable. And so that's a place where SQL, where looking at it like SQL as opposed to looking at it like Malloy is a big difference, and you need to do it differently and expose different, sometimes I call them nouns and verbs, expose different nouns and verbs in the universe of the objects that we're talking about than SQL does in order to make the language better. There, I said that.
Are you tired of data migrations that drag on for months or even years? What if I told you there's a way to cut that timeline by up to a factor of 6 while guaranteeing accuracy? Datafold's Migration Agent is the only AI-powered solution that doesn't just translate your code, it validates every single data point to ensure perfect parity between your old and new systems. Whether you're moving from Oracle to Snowflake, migrating stored procedures to dbt, or handling complex multi-system migrations, they deliver production-ready code with a guaranteed timeline and fixed price. Stop burning budget on endless consulting hours. Visit dataengineeringpodcast.com/datafold to book a demo and see how they turn months-long migration nightmares into week-long success stories. And then another aspect of building any sort of programming language is the ecosystem and the tooling around it and the capabilities of what it can integrate with. And I'm interested in how you're thinking about that as far as Malloy and the adoption of it and some of the, I guess, stumbling blocks or challenges of being a new language and in particular targeting a very prominent existing audience and existing set of workflows and tool chains.
Yeah, that great. You're really good at what you do because these are great questions. So currently, Malloy is written entirely in TypeScript. If you have a TypeScript runtime, you can compile Malloy to SQL, you can run queries, and you can get the data back from your queries and process them into charts and things. That's all sitting in one TypeScript runtime. And there were a couple reasons that we made that decision. One was Looker was entirely written in Ruby because it was the cool language 1,000 years ago when we started Looker, and so we understood a lot of the. And I have a deep love for Ruby. There's something really poetic about that language, which I'll always cherish. But in terms of a foundation for an application, that we weren't entirely happy with all the things about Ruby. And so we on purpose picked TypeScript because it felt to us like this was a language that was powerful enough that it wasn't going to get in our way, but that the type checking in TypeScript and the extension of type checking to actual interfaces as opposed to just functions and variables was just a super powerful tool that was going to let us do things. And we just felt like it looked like TypeScript runtimes were going to be everywhere. And if we ran in TypeScript, we could run all the places that Malloy needed to go, we would be able to get there with TypeScript. And we just have gotten a tremendous benefits from that one decision. Today, if I could have a wish, I don't know if I would have wished that we had done it all in Python, because today a lot of the really important and interesting work that's happening in database happens centered around Python. And if Malloy, and you can download a Python package and compile Malloy, but that Python package works by having a node runtime and talking to it and then getting the data out of the node runtime and putting in the Python thing, which I'm not the marketing guy for Malloy. That's just a bad way to do stuff. It's a nice demo of capabilities, but it doesn't feel great to me as a software engineer for the thing that I would like to ship to people. But if I were in Python, all the things that we can do right now because we're in TypeScript, we would kind of lose because WASM compiled Python works, right? In the same way that using Malloy from Python works. It's not pleasant. And so, I don't know, in an infinitely great world, we would have two parallel implementations of Malloy. One was in pure Python and one was in pure TypeScript. And then there was some way to keep them in sync. I don't know what the right answer to that is. Although I have an LLM context. I have it where I just talk about this problem to the LLM and I say, hey, what about truffle? Hey, what about if we did this like this, what would it do that? And then in the end, I say, yeah, but if we did that, this would be a problem. At the end, the LLM says, yeah, it looks like you have a big problem. I don't know if it's solvable, but I keep dreaming that there's some way that it is solvable. There's only one piece of core Malloy and it's sort of available everywhere to all people.
Seems like the natural next step would be to just rewrite it all in Rust, and then you can compile to a WASM binary and link it to Python.
That was one of the LLM's suggestions was to rewrite everything in Rust. And that's actually, yeah. Well, at that time I went, okay, I understand the size and scope of that project, and I can't afford to stop working on Malloy long enough to take the time to do that. But I hope that someday somebody says it's time to do that, and the day that somebody does that is the day that I know that Malloy has won. And so my goal is for that to be a real project. But you went right to the thing that it took an LLM and I days to come to, so that was quite insightful.
And the other aspect of language ecosystem and integration is the set of tool chains around it, where being in TypeScript, obviously there are a lot of potentials for integrating, particularly in front end style applications. I know that you have a VS Code plugin, which I'm sure was a very natural extension given the language that you're working with. But I'm also interested in things such as how it's being integrated into orchestration tools and data workflows, and whether this is largely being used in the context of interactive notebooks for people who are doing exploratory analysis and then generating data visualizations, or if it is a potential replacement or augmentation to something like a DBT for being able to be the actual transformation engine for a sequence of data workflows, etc.
Yeah, well, the marketing answer is all of those, but the real answer is we have a VS Code plugin which works as a sort of an IDE to Malloy, and then we have an extension to our extension which lets you open up notebooks. So I can have some text and some Malloy query and some text in a Malloy query, and I can successively transform data in the course of a notebook. And there have been experiments, and I'm not up on all of integrating with Python notebooks with Malloy. So if Malloy is the right way to write a query, there's a way to use Malloy in a notebook-like situation. And if it doesn't work in your notebook today, it wouldn't be that hard because the core runtime is already browser resident, right? So that's a goodness. For transformation pipelines, the unit of because transformation pipelines are operating on SQL, the one of the units of transformation is a table, right? And Malloy works natively with tables because otherwise it wouldn't be interesting. And so you can write any stage of a transformation pipeline in Malloy. And for that job, if your transformation is at all complicated, Malloy is a great language to write a stage of a transformation pipeline. But there are lots of people who we have pull quotes from people who write SQL for a living, and a very common pull quote is, if I could figure out how to never write SQL again and program in Malloy the rest of my life, I'd be the happiest guy ever. But the problem of saying that the table is the unit of transformation is back to what I said at the beginning, that data experiences are interactive and ongoing. And so as soon as I make a table, all of the context I use to create that table is gone. All I have is the endpoint. And so if I then want to ask a different question of that table, which the context that produced the table could have answered, but the table can't answer, if all I have is the table, I can't answer the next question. And so in Michael's imaginary future world, transformation pipelines are centered around Malloy and not around SQL, so that the context continues to move down the chain. And so you could make decisions like, what aggregation level do I want to do different computations at, because you have access to all the computations that produce this answer, and all the connections, and you can make efficient things about that. Today, because we do just read and write SQL, anytime you just want to do a transformation from one kind of SQL to another kind of SQL, we have a command line version of Malloy, and you could use it with DBT to do that. But the other thing that's happening with Malloy is, and this is maybe a problem with our vision, is that it's not focused on a particular application, but on a way of thinking about data. Are the places where Malloy exists, uh, we've gone wide but not deep. So there's a thing called Malloy CLI, which lets you, run Malloy queries from a Unix command prompt, but it's not really well integrated with DBT. And today, somebody really should just say, if you want to do DBT pipelines with Malloy, here's the plugin and you're done. We didn't do that. We said, let's spend a day and a half, well, maybe 4 days, I don't know, some small period of time making a CLI version of Malloy and stick it up on the repository and move on. And there's a lot of that in Malloy, where we can sort of demo, here's what it would look like if Malloy sat in your universe, but there is no universe where Malloy is really sitting, where it's fully polished. The most polished experience for Malloy is the VS Code extension, because that's where we sit.
I think another interesting aspect of that whole question is also where I think Malloy does have a lot of strengths is that question of the semantic layer, where it has been a bolt on to things like DBT or a completely separate environment or a whole bunch of YAML with some SQL if you want to have a metrics layer. And then another angle of the overall problem that DBT, for instance, is solving is I'm hesitant to say lineage tracking because there are a lot of gaps in terms of DBT's out of the box capabilities, but that ability to understand the sequencing of transformations and managing their orchestration. And then to add another layer on this, the recent acquisition of the SDF project that added a lot of very enriched type details where you could, for instance, flag a column as having PII of a certain type and then have that propagate through that orchestration graph so that at the end result table, 5 steps removed from the source system, you still have information about whether that is PII so that you can apply appropriate controls or various other type constraints, et cetera. And I'm just wondering how you're thinking about the potential for Malloy to be able to address any or all of those capabilities.
Yeah, okay, so that's a really big thing, and so I'm a guarantee you I'm gonna forget what I'm doing on the way to this one. One of the interesting things about Malloy is that we can attach random metadata to things that you query, sort of at the, let's call it the table level. At Malloy, it's called a source, and a column level as well. And so there is a way to sort of attach arbitrary metadata that you can attach business logic to sort of any part of a query, and it sort of carries along through the query. And and this is just our experience in the universe of doing lookers, like we kind of know what capabilities you're going to need to build these data applications on. And so we're creating these mechanisms, but there's no thing on top of the mechanism. There's just a mechanism going. I'm pretty sure this mechanism is going to scale to answer a whole bunch of problems. I've already lost this thread. Let's go right back to the question.
There are a number of layers that I threw at you.
Yeah,
So the first one I think was the managing of sequencing of transformations so that being able to, for instance, use the source element in Malloy to
right.
understand that I have to wait until this previous stage has executed before I can
Right.
actually have that source present to be able to execute the next stage. And then on top of that, being able to incorporate some of the rich type information and annotations of a particular column that doesn't exist within the data itself. So being able to attach richer metadata to be able to have that flow through the overall execution
All
graph.
right. Well, and the other thing is about this distinction now we have that we're trying to do where there's semantic modeling or metrics definitions. So we're all sort of wrestling with the same problem, which again I mentioned at the beginning is that data experiences are interactive and ongoing, and that the way that data is, and the other interesting is that the way that data is written into a database, right, is here are the pieces of data that I have. I need to put this on a disk right now because I have better things to do with my life. And I don't know what anyone's going to want to compute from this, but I know that this piece of data, like, what time I did this and how many molecules there were in the air at that instant in time, needs to be written down, and people will be able. So there's the data and then there's the information that we need, which is, always some sort of computation and aggregation on those. And we would love to be able to think about data as the information that we care about, and not as the numbers that were used to produce it. And so this idea of a semantic model where I can think about data in the way that's meaningful to me as my business or whatever my activity is, and not care that that's not the way it's stored, right? I can pretend that it's stored like the thing that I care about is a sort of a bolt on. It's like, oh, you have SQL and then you have this other thing. But in Malloy, that's integrated. And anytime that I think about, oh, I would really like to be able to think about as if this column existed and it's actually a computation of these other things with this join, but let's just pretend it's a column. In Malloy, as soon as you write that, it essentially is a column. It acts like a column. You don't know that it's not a column. Everyone in the universe can treat it like a column. And so, and the way that this interacts with the idea that data is iterative is that in asking a question about this, like I'd like to know this thing, and it's essentially a column, I have now made the data world richer because I answered that question, and now my answer to that question is part of the landscape that I'm standing on to answer the next question. And so it's not, the table is over here and the answers are over here. It's as we ask questions, the table gets better. And so we have a slightly different, one of the things we said early on in mention of Malloy is that a semantic model without a semantic query language is not interesting, that the semantic model and the query language need to be integrated. And we don't really have all the insights about why we were saying that, but we were saying that a lot. And I think the thing that I'm saying now about data experiences being interactive and ongoing is a better way to encapsulate that. That felt like that's the answer I wanted to say.
I think circling back around to the construct of Malloy as a programming language and a language ecosystem, the other question then becomes that of packaging, where what is the unit of exchange for being able to say, I have a defined set of queries that will give you a useful view on this set of common data where maybe somebody has an export of their HubSpot or their Salesforce data. Here's the set of views and queries that will give you useful insights about that out of the box that you can then build on top of. How do I now take that, package it up, post it somewhere that somebody else can just download it and start using it in their own work?
Okay, that's a great question, and I'm the right person to answer. So we're trying not to invent the universe where we don't need to. And so we have an import statement where you can say, hey, there's another collection of Malloy, and there's these objects in there that are interesting to me. Please import them into this thing. So I lost a fight inside of the Malloy team about the word model, because model means anything. If you could read all the code from whatever you're interacting with on your thing all the way down to the to the bits, the meaning of model would change 6 times by the time you got down to the bits. Everyone uses the word model and it means nothing, right? And so one of the things I said is, can we please not use the word model anywhere in Malloy? Let everyone else use the word model in any way that they want, but for the thing that they were calling model internally now, let's use a different word. I lost. So in Malloy, a model is represented by one file, say, and it's sort of like a JavaScript model in that it has objects that are defined, and it can import objects from other models into its scope in order to do the modeling and computation that you have. And a model consists of basically queries and sources that answer a particular question. One of the interesting things about Malloy is that there's this idea that I could, like, let's pretend I had this brilliant insight about how to do computations on two-way markets with where buyers and sellers are selling to each other, and I had this brilliant idea about how to do that. You could define an abstract model that says, here's everything I need to know about two-way markets. I just don't know what your users are and what the transaction is and what the value of the transaction is. If you write those 3 things, right, then you can use my two-way market things and you can get graphs and stuff. So that there's a way in Malloy to sort of have sort of abstract business logic that's abstract from all business, right? And you can map it to that. And so there's this composition at the composition blocks are a source, and a source. The simplest source is a table. It's a set of columns and a schema. But instantly in Malloy, you start saying, well, there's a thing, which is if something has no ship date and this and that, then there's a Boolean flag that I would like to imagine as a column, because I'm going to want to filter on that Boolean flag. And so I'm going to say, here's the Boolean expression for that flag, and that's now like a column in the database. Or, here's the revenue computation, or here's the value of this transaction, which is some secret thing. And so you extend sources, and this isn't a query. This is just saying, here's different computations that are interesting to do on this, or here's an interesting aggregation. And also the other thing that happens in a source is that in Malloy, the user view of data, and this is really important, I should have said this an hour ago, all data is hierarchical, right? It's not stored in hierarchical form for reasons. And for any particular kind of data, sometimes it's better to store it normalized, and sometimes it's better to store it, as a graph. And one of the problems with SQL is that those 2 ways of storing data change how you can interact with the data. And in Malloy, that's all data is hierarchical. You treat it like it's hierarchy. There you have dotted paths to things, and whether it's a join or a repeated set of records, it doesn't matter in Malloy. The user view of the data is a hierarchy. And so in a source, one of the things happening in a source is that you're explaining what the graph is that's interesting. I want to join this in, and that join is a source, and it might also have other joins, so all that happens. So there's sources, which end up being these sort of rich descriptions of how you'd like to think about the data. And then there's queries, which are like, given that source, here's some interesting computation, or here's some dashboards and things. And then the other interesting thing about Malloy is that a query is a source, because the output of a query is just a table, and that can be the place for a new piece of modeling. And so there's the circularity. So when you're doing a model, I hate that word, in Malloy, you start with some sources, and then you write some queries, and maybe you're pulling some of your sources are just tables, or maybe they're sources that have been described in other models. That answer the question? I think so.
Yeah. And the other aspect of Malloy, and particularly to your point of data being hierarchical and the restrictions of having these flat representations, is that it has led to a proliferation of various opinions on how best to structure your data, particularly for analytical use cases where we have star schemas, snowflake schemas, data vault, anchor modeling, etc. And once you move to a workflow where you do have that hierarchical capability modeled into the language itself, how does that change the ways that teams think about the fundamental structure of their data at the storage layer?
I'm really happy to say I'm the wrong person to answer that question. So I am so deep in, how do I parse this computer language that we've invented into this other computer language that exists in the world, and how do we make sure that the people who write this computer language, user-facing things, have good user experiences, and how to make sure that the code we generate is efficient and runs. I know everything about that. I actually don't have a lot of conversations with people who write Malloy. So I feel kind of lucky because I get to dodge the question, but I'm also like really honest. Like if I answered that question, I'd just be making crap up.
Fair enough. Well, from your experience of building this tool chain, working with the people who you have been exposed to who are actually building with it, what are some of the most interesting or innovative or unexpected ways that you've seen it used?
There are more than I can count on two hands, but not enough people to fill an interesting concert hall. People in the world who use Malloy for daily work to find answers to questions that they don't know the answer to. They know that it's hidden somewhere in the data. And I am continually thrilled to like I am just thrilled every time there's another person that pops up and says, "Oh my gosh, I could never have answered this question without Malloy. Thank you for existing." But the most surprising thing, which was completely accidental, it just happened to be at the right place at the right time, is because Malloy is designed for humans to understand. It turns out to be a really good target for LLMs to generate. Like I want to make a really good query experience for users, and I want them to interact in a natural language. And then I want to generate something which actually generates queries. There are a number of efforts in the universe of people saying Malloy is the correct semantic layer for us because it's both a semantic layer and a query language. So once something is described in Malloy, it can also be queried in Malloy, and it's working really well in a number of places, which was a surprise to me because I didn't know what an AI was at all when we started Malloy, however many years ago it was, even though that's sort of the time that AIs were starting to become smart enough to be useful. So that's probably the biggest surprise is how useful it is in the AI world because it was never designed for that. And it's just an artifact of the fact that because it's designed to work like a human brain and LLMs are some kind of mapping of the human brain, that it's really useful that way.
You're a developer who wants to innovate. Instead, you're stuck fixing bottlenecks and fighting legacy code. MongoDB can help. It's a flexible, unified platform that's built for developers by developers. MongoDB is asset compliant, enterprise ready, with the capabilities you need to ship AI apps fast. That's why so many of the Fortune 500 trust MongoDB with their most critical workloads. Ready to think outside rows and columns? Start building at mongodb.com/build today. And in your experience of working on this project, building this language, exploring this problem space, what are some of the most interesting or unexpected or challenging lessons that you've learned personally?
Oh my gosh. So I've written about this. I'm just going to say some things that I've said before. There's a great thing and a horrible thing about designing things for people to use. And the good day, the great day when you're making tools is when you see people getting stuff done with the tool that you made and see them feeling like, oh wow, I've got, I'm more productive or I'm exactly as productive, but I'm happier, right? It's like, oh, I feel like I just made the world better, and I love that. But the other problem is that people don't want to learn new things. Like some people do. Some people like the best thing in the world is, yesterday I solved this problem in language A, and today I'm going to solve it in language B. And if I could solve it in language C tomorrow, I'd be happier, and I'll be sad when there are no more ways to solve this problem, right? But other people, especially like the people that I really care about, which is like I'm trying to get stuff done and someone's paying me and I want to do that well. And I actually honor and respect the person who's paying me by not wasting a lot of time learning how to do this in 32 different languages, but being really expert at doing it with the tools that I have. And so when I ask that person to learn a new thing, their first question is, can you please not ask me to learn a new thing, but also help me? And so trying to figure out when something is important enough to say, hey, please learn a new thing right now, it's going to make your life better. And when to say, I'm just going to do it your way. So there's lots of places where we've made that decision wrong, or could theoretically have made it wrong in terms of, like, we're going to ask SQL people to say that thing that they always say one way in another way. Like, let's just, as an example, let's just take the case statement in SQL. There is not a case statement in Malloy. There's a thing called a pick statement, which I think if you search for Michael Toy in the universe, there's I did a High-Trad Boy presentation about Malloy, and I ended with waxing eloquent about how much I loved the pick statement, because it's this beautiful thing that's kind of like a case statement where you get to, say, when data looks like this, the results should be like this. And I think it's just incredibly elegant and beautiful. And it's a disservice to all SQL people that I don't just have a case statement, right? And it's because I'm so much in love with the pick statement that it would feel like I would be desecrating my beautiful language to put the pick statement in, put the case statement in. But really, there should just be a case statement in Malloy. And so sometimes when I've made that decision, I feel like I've made the right decision. The way that we do null comparisons in Malloy, if you say X not equal null in SQL, X is null, the answer to that is null. And in Malloy, if you say X is not equal null, the answer to that is false, right? If it's not null, and true if it is null. And so we have an opinion about Booleans, which is different than SQL, which mostly people are appreciative of, because they're having to work around the fact that SQL has this weird thing with Booleans. And so I'm okay with the weird decision we made about Booleans, which is different than SQL, because there's the way to get the SQL behavior for the 3 people in the universe who want Booleans to be a 3-state value, right? And then everyone else who just wants Booleans to be Booleans can treat them like they're Booleans, and it works. But it's really hard to know, and you often have to do it wrong before you do it right. Like, there's just no way to know except to put it in front of users and go, oh, that was wrong. I was really passionate about that. For me, if it were my programming language, it would always work that way. But this isn't my programming language. This is a programming language for people who are engaged in data, and I need to listen to them when they tell me I was wrong.
And for people who are interested in not fighting with SQL all of the time, what are the cases where you would say that Malloy is the wrong choice?
Yeah, okay. So if I had my marketing hat on, I'd say, oh, Malloy is always the right choice. But the reality is that right now, unless you are a full-time data explorer, or unless you're really excited about the possibility of Malloy and you want to help us refine the vision of what Malloy does and also help us to get there, it's the wrong choice. It's a super powerful language. It does a lot of things. It's wide but not deep, and it's full of possibility. But again, if you're a full-time data explorer and you have the ability to choose your own tools, then Malloy is 100% the right choice. Right now, Lloyd is off doing some consulting for another company, and they said, well, what are we doing? Help us understand what we do, because he, has started billion-dollar companies. He's a very valuable thing. And the first thing he does is like, okay, well, if I want to answer any of those questions, first I need to look at your data with Malloy, right? And now I can start to answer real questions and produce a space where when you ask me the next question, I can answer that. So I hate that most of the things you do with data, Malloy is the wrong choice. But the vision of Malloy is it would eventually be the right choice everywhere, except for the 10 people who are really good at writing optimized SQL, and that you need those people somewhere. And hopefully 2 of those guys are working on the Malloy compiler.
And so, given all of the potential, given the fact that it is, in your words, not the absolute right answer for everyone all the time, yet, what are some of the things you have planned for the near to medium term, or any particular projects or problem areas that you're excited to explore?
Well, right now there's an active discussion about dimensional filtering. It turns out, and this is something we learned at Looker, and we haven't really folded it into Malloy because we didn't really understand what we learned at Looker. When you're doing a query, one of the interesting things about a query is what dimensional filtering, what filtering are you doing to reduce the amount of data? And it turns out that filter itself is a really interesting piece of metadata, because, for example, when I join one thing, there might be an entity in that join that would like to have that same filter applied to it. And if I change how I'm looking at the data as a whole, I would like that join to have that same change. And that's just one example of a place where this idea of having enough data about your sort of low detail data about your filtering to have that sort of be part of the modeling of your data. So then in this case, what you're modeling is a user's glance into data and in what ways that should change how the data looks. And so we're really close, I think, to having nouns and verbs, to use my language, for dimensional filtering, and then surfacing that in the language so that, again, as users look at data, then they are modeling, hey, this is an interesting way to look at data, and we should remember that and make that available to the next person who comes by. So that's one thing. Aggregation is super important. We've been working with big companies. We were sitting inside Google as a sort of research project for a while, and then we were sitting inside Meta as a research project for a while. And so we had a chance to sort of measure Malloy against some of the biggest data sets on the planet. And the way that people deal with giant sets of data is that they make successive kinds of aggregations. And there's an experiment in Malloy called composite sources, where if you have data that's aggregated at different levels, you can treat it as if it's not aggregated. And then based on the query, it'll select correct aggregation and run the query in the fastest way possible. And that experiment showed us what was brilliant and not brilliant about that idea. But because that's the way data sits, Malloy needs to be better at working in that universe, and we have projects in mind for that. And then all the things that SQL does that you have to currently escape to SQL to that we don't handle very well. For example, like databases have a giant list of functions that you can call, and sometimes it's hard to call a function because Malloy needs to know the data types of everything, and so sometimes it's a little ugly when you need to call a function that Malloy doesn't want you to call. We would like to fix all those little places where people are escaping to SQL to not escape to SQL. The way that we do window functions is a vision for how window functions should work, but it's not complete. And so some of the things you'd like to do, and the way that custom aggregation is really important. We don't really support custom aggregation. I know. Well, we have a list and it's long, and we've been in data for a long time, and we understand they're important. We feel like it's sorted well, like we know what order we want to do things in, but we're not. We're never going to be done.
Well, for anybody who is interested in contributing, my understanding is that Malloy is an open source language, so absolutely, I recommend helping to move this vision forward. I'm very excited for the toolchain that you're building. If there are any specific requests, feel free to throw them out there.
Yeah, and I just want to say the thing about open source is we were open source from day one. One of the things that's unfortunate about LookML is that it is a secret. It's not a hard secret to clone, but we feel like if there's any kind of fear that this thing is proprietary, it would have just killed it. So even though it was developed inside Google, paid for Google, day one we were open source because we just felt like that was the only way to go forward. If you're going to ask people to trust something, there needs to be some reason for them to not fear. So it's been open source. And up until recently, most of the contributors to the Malloy effort have been people who are on the Malloy team. We're getting better at being an open source community, but we're still learning how to do that. And with all apologies, please come and hang out with us. We're on GitHub and Slack, and we'll do our best to be helpful. And actually, you can show up on Slack and say, hey, how do I write this query in Malloy, this whole language? I can't be bothered to read the documentation, and we'll help you there too.
Are there any other aspects of the work that you're doing on Malloy, or the overall vision for it, or the ecosystem around it that we didn't discuss yet that you'd like to cover before we close out the show?
No, my brain is a dead sponge at this point. You sucked me dry. Thanks.
All right. Well, thank you very much for taking the time today to join me. Thank you for all of the great work that you're putting into Malloy. I'm very excited to see the project continue to grow. I've been monitoring it for a long time now, so I appreciate all the time and energy that you and the rest of the team are putting into that, and I hope you enjoy the rest of your day.
Oh, thanks for letting me ramble. This was fun.
Thank you for listening, and don't forget to check out our other shows. Podcast.net covers the Python language, its community, and the innovative ways it is being used. And the AI Engineering Podcast is your guide to the fast-moving world of building AI systems. Visit the site to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story.
And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.